This recording is for the students in ACST1052 Introduction to Actuarial Studies. This is an example of using the Excel solver to find the internal rate of return. The internal rate of return is financial jargon. It really means the rate of interest which equates the accumulated value of a series of payments to a specified value. So typically what happens is we've put certain amounts of money into an account over several years, and we know the account balance at the end is, say, a particular value, and we want to know what interest rate we earned on that account which produced that accumulated value. So let's suppose we do this example. We know that we've made these payments. At time 5 we paid 1,000, at time 8 we paid 5,000, at time 9 we paid 1,800, at time 12 we paid 9,000, at time 14 we paid 2,200, and at time 19 we paid 3,100. Now we know the value in our account at time 20 is actually equal to 30,000, and we want to know what was the interest rate that we earned on those payments which produced the accumulated value of 30,000. Now what we're going to do is we're going to start by making a guess. I'm going to guess that the interest rate is 5%. I just picked that number out of thin air. And we're going to see if the interest rate was 5%, what would the accumulated value be? So by now you should be able to work out the accumulated value of all these payments. So using the separate accounts method, we just work out the accumulated value of $1,000 at 5%. So we're going to say that's $1,000 times 1 plus D4. We're going to use whatever interest rate is in cell D4. Remember, you must use a dollar sign by now. You should know about absolute referencing. And that has to be invested for 15 years. So we'll say it's 20 minus B7. Okay, so look at that equation for a minute. It's the amount of the cash flow multiplied by 1 plus the interest rate invested for the period from the time of the payment up till the end of 20 years. Okay, so $1,000 invested from time 5 to time 15 at the interest rate of 5% would be worth $2,078.93 at the end of 20 years. So using the same formula, we can just copy that down. The accumulated value of $5,000 invested at time 8, earning 5% up till the end of 20 years would be $8,979.28. Okay, so we do the same for all 6 of those payments and sum up those accumulated values. We find that if the interest rate had been 5%, we would have $33,637.13 in our account. We actually only have 30,000, so obviously we were unable to earn such a high rate as 5%. Now we could just try changing different interest rates here. We could have put in 4%, and if we've set up our accumulated values correctly, that should instantly recalculate all the accumulated values. And we see that 4% is still too high. We could go through and put in 3%, and we can see that the accumulated value is $28,399.24, which is too low. So we now know that the interest rate earned was somewhere between 3% and 4%. 3% gives an answer that's too low, and 4% gives an answer that's too high. So we could use one of our methods that we learned in TOOTS. We could use binary search, or we could use linear interpolation, or we could use Newton's method to improve our estimate of the correct interest rate. But because I'm kind of lazy, I always like to use a computer to do this kind of stuff for me, and luckily the Excel solver will solve the problem for us in no time at all. So normally what I would do is I would say, okay, what's the difference between the calculated value and the actual value? And I put that in this box called difference. Now, if I have the correct interest rate, then that difference should be 0. The difference between 30,000 and the actual, the accumulated value that was calculated should be 0. If we can achieve that, then we know that we have found the correct interest rate. So we could try, say, 0.035, and that makes the difference negative 377.22. We could try 0.036. That makes the answer minus 125.91. So we could just keep guessing and guessing until we get the difference down to 0. But instead what we're going to do is use the solver. So we go up to your data, solver. We want the value in cell D18 to be set equal to 0 by changing cell D4. Solve. Okay, so the correct interest rate, the internal rate of return here, is 3.6498%. If we wanted to make it look nicer, we could just change that to a percent, show a few decimal points. Okay, so the next thing we want to do is show you the internal rate of return calculation. Excel actually has a built-in function which will calculate the internal rate of return for you. So the IRR function assumes that there's a set of payments which are all equally spaced. So you have to, if you have annual payments, you have to create from time 1 to 19, you have to make a list of those payments with the payments equally spaced, and you have to put in zeros for the years when there are no payments. So we assume that all of these payments go into the account, so they're all positive numbers, and at the end we take out $30,000. So that has to be a negative number. So the IRR function just says, okay, just give me a list of all the payments equally spaced, including the final withdrawal. You can put in a guess if you like, so we'll do the same as before. We'll say the guess is 5%. And as you can see, Excel has instantly calculated the correct internal rate of return, and it's come out with exactly the same answer as using the solver, 3.64977%. both ways. So if you like using IRR, the only drawback is that it assumes that the payments are equally spaced. So it's not very useful if you have payments that are occurring at odd times of the year. So for example, if we were using solver and we had a payment that came in at 8 years and 3 months, we could put 8.25 there as the time of payment. And if we had another payment that came in at 14 years and 7 months, we could put in 14 plus 7 divided by 12 there as the time of payment, and we would still be able to use the solver to determine the internal rate of return. So we could just go up to data, solver, solve, and it would say that if the timing of these payments was different, the internal rate of return would be slightly different to what we expected before. You can't really do that with the IRR function because it assumes that all the payments are equally spaced. There is another Excel function called XIRR, which allows you to calculate the internal rate of return for payments that are not evenly spaced. But I'm not going to show you that at present because in order to use that function you need to know about date functions, which you don't know about yet. So we'll just leave that for the present. Anyway, you don't really need to know that because as an actuarial student we expect you to be able to use this method with the solver, and that works just as well as the IRR function in Excel. Okay, I hope that helps you understand how to use the solver a bit better, and of course let me know if there are any questions. This is the end of the recording.